Hello, I'm Guanhong Tao. I'm presenting our work on mitigating backdoor attacks via trigger reconstruction and model hardening. This is a joint work with Purdue University, Microsoft, Virginia Tech, Columbia University, and Accenture. Backdoor attack is a well-known security problem in AI. For example, given a set of images, a benign model will correctly classify those inputs with their predictions. However, an attacker can maliciously modify the model by injecting a backdoor behavior in the model. When given a set of images, this backdoor model will still correctly classify these inputs. However, whenever a backdoor trigger is injected on the input, the model will produce the wrong predictions, the targeted prediction instead of the correct output. So here the backdoor trigger is a red patch added on the image and the target label is stock. There are more advanced semantic backdoors that apply input independent perturbations on the image. For example, DFST transform the input image shown in the first row into a sunrise kind of style in the second image. And the last image shows the differences between the original image and the backdoor sample. And this is very different from a patch attack where the backdoor trigger is localized into a specific location and it only changes within that location. And the semantic backdoors, they modify all the pixel values on the image and they preserve the semantic meaning of the original image. There are all sorts of attacks, and this is a list of possible attacks. Existing techniques, they have a set of limitations that are less effective against especially semantic backdoors. They rely on neuron isolation. They try to identify and remove the neurons compromise the backdoor attacks. But as we see, those semantic backdoors, they could have backdoor neurons interleaved with benign neurons, make these techniques less effective. And existing techniques also assume feature separation, try to make the model forget the backdoor behavior and retain the original task. However, the recent attacks, they leverage the channels that the normal features actually lie within. Another problem of existing techniques is that they only designed or mainly designed for patch kind of backdoor attacks. And they are not capable of modeling those semantic style-based attacks such as DFST. So we propose a new backdoor mitigation method called Martini. It consists of three components. The first is the construction, where we train a encoder-decoder architecture such that it can reconstruct the input image faithfully. In the second stage, we try to reverse engineer the injected backdoor trigger in the backdoor model. Specifically, we leverage the internal feature representations from the encoder of the original image and modify this features representation using a novel transformation layer. This layer will inject a backdoor features into the original feature representation, and then we use the decoder to reconstruct the feature representations to the image, which will have the both original features and also the backdoor triggers added. With this reconstructed backdoor samples, we leverage the original label, the correct label, to fine-tune the backdoor model such that the backdoor behavior can be removed from the model. We conducted the experiments on 14 types of backdoor attacks and compared with 12 existing state-of-the-art backdoor removal methods. And our method can reduce the attack success rate from 96% to around 5% on average. And the baseline methods can only reduce the attack success rate to 26% at best. We also apply our technique to self-supervised learning, and it can reduce the ASR from 97% to around 9%. and the baseline methods can only reduce the ASR to 29% at best. Thank you very much.